We've talked about the 7 color contrasts, beginning with hue contrast, value contrast, intensity, extension, and temperature, and the other 2 are complementary and simultaneous. 6 out of the 7 function concurrently every time you see color. The issue is whether you're looking at complementary or non-complementary colors, whether or not complementary or simultaneous contrast will kick into action. You're either seeing all of these, or you're seeing these plus this, but not this. So complementary is the after image action on opposite hues, and simultaneous contrast is the after image action on anything else. Just to review the after image effect, this is a painting by Jasper Johns. If you stare at the little white dot in the very center, and keep looking at it, you should see an after image of the US flag. If we look at a color negative from a digital image, this is the positive. So let's talk about complementary contrast. There are a couple general principles of complementary contrast. The hues have to be positional opposites, so you could have a dark green and a pink. You can have a teal and a salmon color, or you can have the fully intense hues. So it's not just the spectral level hues that generate this, it's whether or not the colors themselves are complementary. Hues that are complementary, if you recall, are positional opposites. They're opposite in character. They represent the greatest range of hue contrast. Anything that's directly opposite on the hue circle is as far away from, they're as far away from each other as you can get. They're polar opposites. Complements, when admixed, meaning you're physically mixing them together, will neutralize each other. And when they're juxtaposed or placed side by side, they will enhance each other. And they give complementary after image. In other words, the after image is the complement. So if you're looking at a teal, a blue-green, you're going to be generating a red-orange after image. With complementary contrast, the hues juxtaposed will strengthen each other's apparent intensity. Remember back to saturation? Saturation was the physical state. Intensity is the visual result. There's a difference between the two because you can change the intensity without affecting the saturation via complementary contrast or simultaneous contrast. So we can actually make a color appear, that's the apparent part, more intense or less intense by what we put around it. So with complementary contrast, the hues are going to strengthen each other's appearing or apparent intensity, and there is no hue displacement. All 3 primaries in a complementary pair are proportionally balanced. So between the yellow and the violet, we have yellow and red and blue, and they are equally proportioned, so there's nothing that has to be added or adjusted to make sure that we're in balance. If we look at the yellow on the neutral, we will see that it has a certain amount of intensity. We put that same yellow on its complement, the violet. We notice that now the yellow, especially around the border, the edges start to vibrate. And same thing here with the violet on the gray versus the violet on the complement. There is a lot more visual action going on. Ovals on the bottom do not appear as stable as those that are on the gray. So here we have an intensity, neutrality, contrast. Here we have complementary contrast. This is a cleaned up Michelangelo part of the Sistine Chapel, and it is basically a blue and orange complementary contrast. And notice that the flesh tones and the figures being neutralized, they're chromatic neutrals, kind of sit back and don't pop as far forward as the orange and the blue, and also the yellow in here. But the blue adds intensity to the orange because the after image of blue is orange, and therefore the orange compounds the orange. Makes the yellow look more red because of the red in the orange. And at the same time, right next to the orange garment, there is an intensification of the blue around it. So the blues up here against neutralized colors don't look as intense. Down here they're really popping in a powerful way. And it gets very exciting down here visually. So that's an issue of complementary contrast in action. In this David Moink, it's a 2-page spread from a printed magazine a few years back. Notice that the orange comes forward, the blue sits back, and notice the intensity of the orange against the blue sky. And notice all the variations of blue that are in that sky. So you can create a sense of intensity without even touching the saturation. Look how intense the setting sun appears to be in this scene. All around it is blue, and then we have this pop of brilliant orange made even more intense and shimmery because of the complementary contrast. And we've seen this before. The after image of the green is red. The red's being added to the pigmented color, and therefore the sense of redness, the chromaticity, is appearing much more intense without at all affecting the saturation of the red. So simultaneous contrast is a little bit more complex than complementary contrast, and you have basically two general principles that work in simultaneity. With related hues, you have a sense of desaturation, but it's not desaturation, it's a weakening in the apparent intensity. Things will appear dull. And there is a hue displacement because you have a missing primary. A related hue is a single hue family, such as the green on the gray or the blue on the gray. Or where you have two or more hues, such as the green and the blue-green, containing no more than two primaries. So the green has yellow and blue, the blue-green has yellow and blue, but they have yellow and blue in different proportions, thus making them different hues. In this case, both the green and the blue-green have both primaries in common. They both have yellow and blue. Red doesn't exist. So what's going to happen is that the blue-green will impose a red-orange after image because red-orange is the complement of blue-green. So it's like mixing the red-orange into the green. And if you mix red-orange into the green, you'll start neutralizing the green if you were actually admixing pigments. But this is happening in your eye, in your perception. So the green is going to appear more dull than it does on a neutral ground or in isolation. Remember, we never really see color in isolation. It's always against some sort of ground. In this case, the blue and the green, we have only two primaries present. So we have blue and yellow. The green is imposing its afterimage, its complement, red, onto the blue. And if you compare this blue with this one, this should be looking almost blue-violet, whereas this is not. So there's a lot more red going on in here perceptually, but it's not being admixed in. It's not a physical addition of red to blue. It is a perception being caused by the green. So with related hues, where you have either a single hue family, whether it's a simple hue or a compound hue, or you have two or more hues where there's only two primaries and at least one held in common, the afterimage will weaken each other's apparent intensity. In other words, they will dull visually, and there will be a hue displacement. In other words, we've shifted from a perception of blue to a perception of blue-violet. Here, we've shifted to a perception of a yellower green and slightly duller than this one. The other principle of simultaneity is with contrasting or opposing hues. And if we look at the hue circle, and we're looking at red, and we've got red, orange, orange, and yellow, orange, and yellow. Well, red and yellow don't share anything. They're two separate hues that don't have anything in common. So they're actually opposing. Red and red-orange, well, red-orange has red, so they're related. Red and orange are related because they both have red, and yellow, orange, and red are related because they both have red. Red, violet, and red are related because they both have red, and red also relates all the way around until it gets to blue, and now there's no red in blue and no blue in red, so those are opposing. So if you have standalone primaries, that's an opposing or contrasting color scheme. If you have anything that has the third primary in it, in other words, we've got red-orange, and if we go over here to the yellow, well, red-orange has yellow in it, so that's a related hue. But if we go to the yellow-green and red-orange are opposing because now we've introduced the blue primary. So anything in relationship to red-orange, anything that has blue is an opposing. Even though red-orange and red-violet have red, red-violet also has blue. So between red-orange and red-violet, we have all three primaries, red and yellow, and red and blue. So we're not related, we're opposing. Okay, so when you have contrasting or opposing hues, and they're not direct complements, they're not opposites, they are going to strengthen each other's apparent intensity rather than dull it out. And there will be a hue displacement, which means there's a shifting, a visual perception of the hue being actually different than it is. So if we look at the yellow-orange on the gray is not causing a shifting of hue. The only thing it's doing is causing this to appear a little lighter. If we look at the yellow-orange on the blue-green, the yellow-orange should look a little redder than this, but it's also intensifying. You can see that it starts to kind of flutter. It kind of vibrates around the edges. So it is not sitting comfortably within the space. If we look at the blue-green here, and we look at this has a sense of increased intensity. This seems to pop more. And because of the after image of the yellow-orange, which is blue-violet, the blue-green is now appearing bluer than the blue-green here. So we look at this non-objective painting and we can see all sorts of opportunity for both complementary and simultaneous contrasts. And also remember, we've got hue contrast, temperature contrast, extension contrast, intensity contrast. All of those are also operating. Between the red and the orange and peachy color in here, we have simultaneous related. Between the red and the blue, we have simultaneous opposing. Between the blue and the yellow-orange, we have simultaneous opposing. Between the orange and the yellow-orange, we have simultaneous related. Between the red and the green, we have complementary. So in any design, in any image, in any painting, we can have simultaneous and complementary contrasts going on in various parts of the painting. Simultaneous and complementary contrasts were responsible for the visual effects of psychedelic art in the 60s. These contrasts were exploited and manipulated to create visual sensations. With the magenta, which is a red, and the blue, you have simultaneous opposing. The blue effect on the magenta is making the magenta really bounce right up in here, especially. There's more blue than magenta, so the effect of blue onto magenta is going to be greater than the magenta on the blue. On the bottom half, however, we have complementary. And the magenta is the same, but it's looking a bit more red. It's looking like it has a greater warmth to it because of the complementary action of the green. So the green's complement is red being imposed on the magenta, so the magenta's in the red family. The red compounds kind of doubles in apparent intensity. Obviously a complementary color scheme, and this is to show you that the idea happens whether you have fully intense, fully saturated colors, or you have tint, shades, tones, and even neutralized colors. So this is still complementary contrast. We have orange and blue in all these related pieces, and here the orange is shaded, here it's toned, here it's tinted, the blue's tinted. A color that comes from a hue family works within the scope of complementary or simultaneity as well. It doesn't have to be just the spectral level hues. Here we have a red, orange, and a yellow. So what's happening is that we have simultaneous related. There's yellow in the red, orange, and then we have the vivid yellow. The yellow is not quite as bright as it would be if, in appearance, its apparent intensity is not as full as if this were an opposing color, as if this were, say, a red-violet, a violet, or a blue. This is a book cover, and we have a yellow-orange and a yellow-green. Now remember, yellow-orange has red and yellow, yellow-green has blue and yellow. We have all three primaries. It is an opposing color scheme, and therefore it comes under simultaneity, opposing. So they are shifting in terms of hue perception. The yellow-orange is becoming more red in appearance, and the yellow-green right around it is becoming a little more blue in appearance. And they are increasing each other's apparent intensity. The effect of the blue on the yellow-green, however, is simultaneous related, so they are dulling each other out. So we've talked a little bit about the dynamic motion of color. We've talked about how certain colors advance, other colors recede. Warm colors advance, cool colors recede. Light colors come forward out of dark colors come forward out of light colors. Color dynamics deals with the spatial position of color separate from an object that the color appears on. If this is really close to you and this is further away, red advances. Orange advances but not quite as much. Yellow advances but not quite as much as orange. And yellow-green starts to sit a little bit in mid-ground, although it has some advancing forward motion. You'll see all these four colors before you'll see any of these. Green is a stable color. It has no advancing motion, it has no receding motion. Blue-green starts to recede. It does not advance, and blue recedes and violet recedes. Black sits way far away. If you notice, these are kind of in spectral sequence. Here we have our long wavelengths, and here we have our short wavelengths. Long wavelengths we see more quickly. We see them further away. The International Highway signage system is based on color dynamics. The things that you need to see most quickly and respond to, or have a greater distance to respond to, are red. Stop signs, red lights, brake lights. Things where you need to sit up and take notice and proceed with caution, such as road construction, it's orange. Freeway signs are all green with white lettering. Next exit, that type of thing. Depending upon how they're used, neutrals and chromatic neutrals can sit anywhere. So keep in mind when you're dealing with color and space and visual hierarchy and ordering that color, separate from the object that it's perceived on, has a dynamic function, a spatial positioning, spatial movement to it.